Today we'll start with the unit 1. Unit
Okay.
1, 3 or else 2 units from the block 1 and 2 units from the block 2 will try to complete by Saturday. On Saturday,
Okay,
the important that is what are the topics covered for the 10 marks questions that we'll see that is fourth block on the last Sunday is the last no class.
Yes,
Okay,
ma'am.
next on next Sunday we'll see the important questions from all the blocks, each and every block, 5 marks and 10 marks, and also objective type I'll tell. And Saturday you want the only fourth block.
Yes, ma'am.
Third block you have understood the concepts, no?
Yes, ma'am.
Okay, in fourth block you have one is the formation of the partial differential equation is there. It is somewhat similar to the formation of differential equation. So we have done now that two constants will be there. You have to create the constants and you have to frame it in the
Yes,
form of differential equation. Same, it will be similar to that is partial differential equation. There we will do the partial. That means with what variable differentiation that will be there. Okay, I'll tell that concept.
Okay, ma'am.
One 5 marks question and one 10 marks question I'll tell you.
Okay, ma'am. Thank you.
Okay. So today we'll see the block 1. So block 1 already we know that it is a integration we have in that unit 1 and unit 2 are the methods of integration. So in unit 1 or else even you may get in unit 2 also, means it may be from unit 1 or unit 2 10 marks question will be there, but unit 3 is the compulsory 10 marks question. Okay, so that is regarding of the areas, we will get the question on that. And in the methods of integration, that is a partial fractions is there, no, that type of question you will get for the 10 marks question. Or else one is the reduction we have seen, no, that is definite integration a to b f of x dx we have seen with the help of the limits. That question also you will get for the 10 marks question. Okay, so we have at the time of the introduction I have told what is the integration. We already know that general definition of the integration is that integration is a method of adding or summing up the parts to find the whole. Okay, so we'll have indefinite integration, we'll have the limits, and indefinite integration will not have the limits. Okay, so definite integration will have the limits. So that is the difference between these two. So methods of integration unit 1, methods of. So in textbook you have that is another definition is there. So that is the definition. If it is asked in the examination, you have to write the definition regarding of the indefinite integral. Okay. So for the integration, if it is indefinite, you can call it as integrals or integration. Okay. So in this, you will not have the limits, only f of x dx equals to capital F of x plus c. Okay. This is integrand we call, this is the function, and this is the whatever the resultant you are getting, this one, this is the constant of integration. Okay, so in indefinite integration you are not having the limits, that's why we'll put here it as a c, that is it is called as a constant of integration. Okay, so if you see the definite integration, you will have the limits a to b f of x dx is equals to, that is whatever the resultant you will get, you will write the a to b. So we'll not write here plus c. Why? Because here already limits are there. If limits are there, means we'll not use the constant of integration. Okay. So and also we know there is an integration and also differentiation. Both are reverse process. Okay. If any function is there, generally we'll write the function as y is equals to f of x. Okay. So here it is the independent variable and this is the dependent variable, and here this is the functions, different type of functions will be there, no? So those functions, so usually we represent it as y equals to f of x, and here the functions are 5 types are there. There is the first one is the constant function, we deal with these. Second one is the polynomials. Okay, third one is the trigonometric functions, and fourth one is the logarithmic functions, and fifth one is the exponential functions. Okay, Constant means C or K or anything you can take. Polynomial, they will be in the form of x to the power of n. Trigonometry means sin x, cos x, all trigonometric functions are there, no? Those. And logarithmic is we deal with log x, and exponential means e to the power of x. Okay. So these 5 types of functions will deal in the differentiation and also integration. So you have formulas are there. So try to compulsory remember those formulas of differentiation and also integration. And also, if any function is there like this, f of x is any function. So for that function, if you do the differentiation, we'll get it as f dash of x. Okay. For this f dash of x, if you do the integration, okay, this is differentiation. For a function, if you do the differentiation, we'll get f dash of x. For f dash of x, if you do the integration, you will get again this function. Okay, this is the process from here to here and from here to here. So this is differentiation and this is integration. Okay, so just if you understand the concepts, it's enough. And for these 5 different types of functions, you have the formulas are there. So constant differentiation is 0, constant integration is the variable, and polynomial, that is x to the power of n means tabular form it is there, no, page number 4. So try to see that one. So that is a very important one. You may get even in the objective type of questions also. Okay. So see the definition from your textbook, indefinite integration. And next we have properties are there, properties of the integration. These two are somewhat similar to the differentiation only. Only 2 properties are there. That is, if 2 functions are given, they have that is addition or subtraction in between of them. Just you have to separate those 2 functions and then you have to find the integration. That is f plus or minus g of x into dx is equals to, we have to integrate the function as f of x into dx plus or minus integration of g of x into dx plus c. Okay. So if 2 functions, it may be logarithmic or it may be trigonometric function, then this is the one property. Okay. So second one is, if you have any constant term and also function. Dx. Okay. This a is any real number. So next we have the function. If it is there means we have to take outside the constant term and also f of x into dx. That means you can take here 2 into x is there into dx. Then 2 you can take outside and then you have to find the differentiation of the x term. Okay. So on this also you have the example problems are there. Such type of problems you may get for the even objective type of questions. Okay. So next, after these 2 properties, you have the methods of integration are there. So in these methods, first one is you have the substitution method. Okay. In substitution method, 2 different methods are there. First one is the algebraic and simple trigonometric functions. Okay. So for this, you have formula is there, that is integration of method of substitution. Okay, method of substitution. So in this, the formula is integration of f of g of x into g dash of x into dx. Okay. If any function is given in this form, this is f is one function, g is another function. Okay. F is one, you may have the that is a exponential function or else trigonometric function or logarithm again. In those 5 different type of functions, 2 different functions will be there. So means it should be combination of these 3 terms. First one is the function of second function and into its derivative. Okay. If it have in this form, then you will get the resultant as it is equals to integration of f of t into dt. Okay. So function of second function and its derivative, if it is in this form, then the whatever the resultant you will get, that is the integration of f of t into dt. So you can take here one example. Integration of 2x into cos of 1 plus x square into dx. Okay, so here just you rewrite this one as like this. You can write cos of 1 plus x square into 2x into dx. Okay, now you see it is in the form of this function of, here function is cos. Okay, cos of whatever here one more function is there, that is 1 plus x square. Okay, and its derivative 1 plus x square derivative is 2x. So it is in the form of f of g of x and g dash of x. So we have to write it in the form of integration of f of t into dt. T, how you will get? So whatever the g of x term is there, that term you have to take it as t. Okay. So here, first you write here the solution. What is g of x? G of x equals to 1 plus x square. Okay. So that is, we can take t is equals to 1 plus x square. Okay. So what is g dash of x? So already we know g dash of x is 2x. One, that is a constant term is 0, x square is 2x. So it is in the form of f of g of x into g dash of x. So t we are taking it as 1 plus x square. So what is dt? If you do the differentiate this one. So whenever from one variable to you're converting into another variable, that term you have to do the differentiation such that whole whatever the function is there, it will be converted into the assumed variable. Okay. So here wherever x is there, that term should be converted into t. Why? Because you are assuming t as 1 plus x square. Okay. So now if you have any confusion, you can take it as equation 1 and then you write differentiate 1 with respect to x on both sides. So here this is dt. Actually it is dt by dx. When you do the cross multiplication, both dx and dx both will get cancelled. Okay. So dt is equals to 1 differentiation is 0 plus this is 2x. Okay. So it is dt by dx now. Okay. So what you will get if you do the cross multiplication, dt is equals to 2x into dx. So x differentiation is dx by dx. So it is 1. And t differentiation we are doing with respect of x. So dt by dx is equals to 0 plus 2x. So if you do the cross multiplication, dt equals to 2x. So dt equals to 2x into dx. Now substitute these all in the given function. So what will happen? So integration of cos like that only. What is 1 plus x square? 1 plus x square is t. So t. Now here 2x dx is there. From here what we got, 2x into dx is dt. Okay. So now it is converted into this form. That is f of t. This is f of t into dt. So that's why whenever the function is in this form, we have to write it in the form of integration of f of t into dt. So for that, you have to assume the whatever g of x function is there, that function you have to assume it as t. Then whole function will be converted into t variable. Now you have to do the, for getting the solution, we need to do the integration here. So cos t integration is sin t. Okay, sin t plus c. So now what is t? What we have assumed here, it is 1 plus x square. So it is sin 1 plus x square plus c. Okay. So like this, you have to find the answer for such type of problems by the method of substitution. Okay. So this is one formula we have. Next, another one is integration of f dash of x by f of x into d of x. That is also one method. So these, whatever the example problem I have told, you have in your textbook, you can see them. And another one important one is integration of f of ax plus b into dx. So if any function is there in this form like this, f of ax plus b into dx, then the answer for this for integration, whatever term is there, that is here you have the quotient A, no, that you will write as 1 by A into capital F of AX plus B plus C. Okay. So these all formulas you have in your textbook. You can see from there also. Next one, important one is integration of f dash of x by f of x into dx is equals to, this is log f of x plus c. Okay, modulus of log f of x plus c. This is also important one. In many problem solving, we use this formula. Okay, and try to remember this one. For this, you can see one example. See, like this, it is there means example integration of x by 1 plus x square into dx. Okay, this is one function given, it is x by 1 plus x square. Okay, if you see, if you compare this one with the above formula, so if you take denominator, it is 1 plus x square, that is f of x. So when you do the differentiation of this one, f of x is equals to 1 plus x square. Okay, what should be f dash of x? One differentiation is 0 plus x square differentiation is 2x. But in the numerator, you have only x is there. Okay, for such type of problems, you need to multiply and divide with the term which is missing in the question. Okay, to convert it in the form of f dash of x by f of x into dx. So now to convert it to this form, here multiply and divide with divide by 2. Okay, so now you will get 1 by 2 integration of 2x into 1 plus x square dx. Now it is in the form of this formula. Okay, so such type of problems will be also there in which some terms will be missing. So such cases you have to multiply and divide, or anyway you have to make it in the form of this one. Okay, means directly you can apply the formula here. So answer is 1 by 2 log of 1 plus x square plus c. And even you can write this as log 1 plus x square to the power of 1 by 2 plus. Okay, so this is the one method, direct substitution method. Next one is the second method is integration using trigonometric identities. Yesterday I have told you, so to see the intermediate textbook for the trigonometric identities, that is a sin 2x, cos 2x, and also sin 3a, cos 3a. Such type of identities will be useful for solving the problems. So second method of substitution in the second one is by using the trigonometric identities. Okay, you can take here integration of sin square x into dx. Okay, if you see page number 4, you have the formulas are there. There you will not have any formula for sin square x. Sin x is there, but sin square x dx is not there in the integration. Okay, so for such type of problems, you have to convert them into the integration type, means which function can be able to do the integration. Okay, so for that one, we are using the substitution of trigonometric identities. Okay, so for such, means you need to know the identity formulas. So here sin 2a means it is 2 sin a cos a. Okay, but here we have square is there, so sin 2a identity is not applicable here. Next, if you see cos 2a equals to 1 is 2 cos square a minus 1. Another one is 1 minus 2 sin square a. Okay, here sin square x is there. So you can convert this one, that is 1 minus cos 2a by 2. Okay, if you take this term this side, at that time so you'll get it is equals to sin square a. Okay, from this identity, in place of sin square x, we have to write 1 minus cos 2x by 2. Okay, so this is equals to integration of 1 minus cos 2x by, okay, if you want, you write the question also in the solution. Sin square x dx is equals to 1 minus cos 2x into dx. Okay. Here you write from the identity or trigonometric identity. So just you write this formula. Or else here you write. So try to write these all formulas. This will be useful for you. From the identity. From the identity, cos 2x is equals to 1 minus cos 2x by 2. This you write as the formulas. 1 minus 2 sin square x, which give sin square x is equals to 1 minus cos 2x by 2. Okay. This you write as the side part. So therefore, integration of sin square x dx is equals to. Okay. Here you can split this one. Just now we have seen the properties, no? From the properties, that is 1 by 2 minus cos 2x by 2. Okay. Into dx. So it is equals to integration of 1 by 2 dx minus 1 by 2. I have taken this outside, cos 2x into dx. Okay, we are separating this one. So it is equals to, if you take out 1 by 2 outside, it is integration of dx minus 1 by 2. This you keep like this only. 2x into dx. So 1 by 2 is the constant term, and d here it is, if nothing is there means 1, that is constant, 1 is there. So integration of dx is that variable you will get, that is x minus 1 by 2 integration of cos 2x. So cos x differentiation is sin x, and here cos 2x is sin 2x, and in the denominator 2. Okay. So that means 1 by 4 you will get this 2 and that 2, if you multiply, it is equals to 1 by 2x minus 1 by 4 sin 2x. Okay. So like this, you have to find the given function with the help of the trigonometric identities. So cos cube is also there. Next one, cos cube means, just I am writing here the formula. By that you solve that problem. Okay. So cos 3a is able to see again. Cos 3a. Cos 3a is equals to 4 cos cube a minus 3 cos a. And sin 3a is 4 d sin a minus 4 sin cube a. Okay. Even you can see from the textbook also, d sin a minus 4 sin cube a. So with the help of these trigonometric identities, you can try to solve this one, that is cos cube x into dx. Integration of cos cube x dx. So from this identity, you have to convert that one, and same similar process you have to do. Okay. This is about the integration by trigonometric identities. Next, you have integration of algebraic functions or special forms using trigonometric substitution. Okay. So now we use that is sin. Here we have used identities. Okay. So for next one, we'll use the trigonometry functions, that is a sin x, sin theta or cos theta, tan theta, secant theta, and we'll find the formulas. Okay. So next one is you have the formulas in your textbook. Just if it is asked in the examination, how to find this, I will tell. Okay, these formulas you have in your textbook. That is integration of 1 by root of a square minus x square into dx. Okay, so like this, many 5 to 6 formulas are there. 1, 2, 3, 4, 5, 6 formulas are there here. And for this such type of problems, by substituting either sin theta or cos theta or tan theta or secant or cosecant or cot theta, we need to find the formulas for this one. Okay. So here when a square minus x square is there means we'll put here x as equals to a sin theta, or else even you can take a cos theta also. We'll get the similar answer only. So put x equals to a sin theta. So then what will be dx? Okay. So whenever you take it as something compulsory, it should be converted into that variable. Here we are converted into theta. Okay. So that's why do the differentiation dx equals to a cos theta into d theta. Okay. A cos theta into d theta. Now substitute these all values here. So what will happen? Therefore, 1 by root of a square minus x square means a square sin square theta. And what is dx value? Dx value is a cos theta into d theta. That means this whole thing you will get in the numerator. So it is equals to integration of a cos theta into d theta by, this is in the root, if you take out a square common, 1 minus sin square theta. Okay. So it is equals to a cos theta by, if you take a square outside the root, it is a root of 1 minus sin square theta into d theta. Okay. So already you know one identity, that is sin square theta plus cos square theta is equals to 1. So from this, 1 minus sin square theta is cos square theta. Okay. So if you substitute that one, this is equals to integration of a cos theta by a into. So if you put root, what will happen? You will get only cos theta. Or if you have any confusion, you can take it as root of cos square theta into d theta. So it is integration of a cos theta by a into cos square theta, integration is cos theta into d theta. A cos theta will get cancelled. So what is remain here? Only 1 is remain here. 1 into d theta. So integration of constant term is that variable here. So theta plus c. So what is theta from here? So here, so you can write here theta is equals to x by a, that is, you write this like this, x equals to a sin theta. So x by a equals to sin theta implies theta is equals to sin inverse x by a. You are able to see that one. Okay. So x equals to a sin theta. So when you take that a, whatever quotient is there here, it is x by a equals to sin theta. So we need theta value. So theta is equals to sin, from right hand side to when it will come to the left hand side, it will become inverse. Okay. So theta equals to sin inverse x by a. So here theta plus c, no? So it is sin inverse x by a plus c. Okay. So integration of 1 by root of a square minus x square is sin inverse x by a plus c. Actually, this is the formula. Okay. How you will get the integration of sin x is equals to cos x. Okay. Minus cos x, no? That whatever the resultant you are getting, you will get from such type of doing the simplification. Okay. That we will do with the help of the definition of integration. Okay. So these formulas are important. Sometimes for 5 marks question, they will ask even such type of problems also. Okay. So six formulas are there regarding of these. It may be root of 1 by root of a square minus x square. Instead of minus, it will be plus will be there. And here you will have without the root also it will be there. 1 by x square minus x square, or 1 by x square plus x square. Like that, 6 different formulas are there. Okay. So one thing is you have to remember those formulas. Why? Because these formulas we'll use in solving the problems. And another one is how to solve these problems also. It's important. Okay. So next one, just I am writing the formula. I hope you understood this one, how to solve this. Okay, next one is integration of, second one, integration of 1 by root of x square minus a square into dx. Okay, these formulas you have in your textbook also. We can write this as cos h inverse x by a plus c. Okay, two answers are there for this one. You see from the textbook. And one more is, third one is integration of 1 by root of x square plus a square into dx. So this is, you can write sin h inverse x by a plus c. H is here hyperbolic function, okay? Or else one more is, for this I am writing log of x plus root of x square plus a square plus c. Okay? So if you see the textbook, you will have these all formulas you have in your textbook. And fourth one is 1 by x square plus a square. So this is 1 by a tan inverse x by a plus c. Okay, fifth one is 1 by a square minus x square into dx. It is 1 by a tan h inverse x by a plus c. So for all you will have two answers will be there. You can see in the textbook also, a plus x by a minus x plus c. Okay. So last one, sixth one is integration of 1 by x square minus a square into dx. It is 1 by 2a log x minus a by x plus c plus c. Okay. So these 6 are the formulas for the, whenever the problem it is in the form of 1 by root of x square minus a square. That means x square minus 4. So you can convert it in the form of 2 square, you can write now. X square minus 2 square means it will be converted into this form. So you will get the answer as cos h inverse x by 2. Okay. With the examples it is given in the textbook. Okay. Try to see that one. But here for solving these formulas, for which terms you have to put x value as sin theta, cos theta, or tan theta, cot theta, and secant theta and cosecant theta. Okay. For all, if you substitute the sin theta only, means you will not get these answers. So they will vary for each and every formula. So for some formulas, they will use only to substitute the x equals to sin theta or cos theta. Okay. Or either you can use sin theta or cos theta. So for other formulas, you need to substitute tan theta or cot theta. Okay. Third one is you need to substitute secant theta and cosecant theta. So how to identify that? I will give some different steps are there. Means by seeing the question itself, you have to identify whether to substitute it as sin theta or tan theta or secant theta. Okay. So these formulas are important. You write in your notebook. Two formulas are there for each one. So just to identify whether to substitute sin theta or cos theta. So the note is that x is, if it is in the 1 by, you can take. I am writing only like this, but it may be 1 by root also. Okay. So when it is root of a square minus x square here, so here substitute x equals to a sin theta or a cos theta. Okay, when the given question is in the form of only as root of a square minus x square or 1 by root of. Okay. Second one is when it is in the form of 1 minus x square. That is here a value is 1 here. So you need to substitute x equals to sin theta or cos theta. And third one is when it is in the form of a square plus x square. Okay. So you need to substitute here x equals to a tan theta or cot theta. Okay. So similarly, fourth one, root of 1 plus x square means x equals to tan theta or cot theta. Okay. Fifth one, when it is in the form of a root of a minus x by a plus x or root of a plus x by a minus x. Okay. So for such, you need to apply x equals to a cos 2 theta. Okay. Sixth one is root of a square minus x square by a square plus x square or root of a square plus x square by a square minus x square. So we need to apply here x square is equals to a square cos 2 theta. Okay. Last one is seventh one, root of x square minus a square is equals to, that is x equals to a secant theta or a cosecant theta. Okay. So these compulsory, remember this one. So just now before this, whatever the problems I have told, those problems all you will get the answer with the help of these substitutions. If you want, you can check them by seeing the textbook here. The textbook solution is given. So they have substituted either x equals to a sin theta or cos theta or tan theta or secant theta or these values. Okay. So this is the important one. You will get even for the objective type and also 5 marks question will be there. So next, integration of certain algebraic functions of special forms are there. So those are all you take from the textbook and try to solve them. Next one, important one is integration by parts. So okay, yesterday I have given the first day introduction. I have given the formula. Okay. So with the help of that, how to find the integration of two functions at a time. This is called as integration by parts. Integration by parts is integration of f of x into g of x into dx is equals to f of x into integration of g of x dx minus integration of f dash of x into g of x dx into whole dx plus c. Okay. This is the formula. So you can take one any example, that is integration of x into log x dx. Okay. So here this is f of x and this is g of x. Now you substitute here in the formula and then you find that one. So our x is f of x and this is our g of x. So f of x is x into integration of g of x is log x into dx. See here, if in the question itself it is given as x into log x. If I have written like this, that is f of x is x into integration of log x. In the integration, log x is log x formula is not there now. What we have formula, integration of 1 by x into dx is equals to log x. So if you see page number 4, so integration of log x, we don't have any formula. Okay, so when it is given like this, so we can interchange this one, that is log x as f of x and x as gx. Why? Because for x you can do the integration, no? Okay, so if any problems are given like this in which you are unable to get the integration, then you can, why? Because it is multiplication only, no? So you can write this as f of x and that as g of x. Okay, this you can write it as log x into x into dx. Okay, now log x is f of x. Why? Because log x differentiation is 1 by x and this is g of x. So now if you write in the formula, so f of x means log x into integration of g of x, that is x into dx, minus integration of d by dx of f dash of x means this is log x, into integration of x into dx and this whole dx plus. Okay, now if you write log x, x integration is x square by 2. Okay, so minus integration of d by dx of, that is differentiation of log x, is 1 by x into integration of this x, integration of that x is x square by 2 into again one more dx is there, dx plus c. So it is equals to it is x square by 2 into log x, okay, minus integration of this 1x and 1x, both will get cancelled, so it is x by 2. So x by 2 into dx plus c. So it is equals to x square by 2 log x minus, you take out 1 by 2 outside, so x into dx plus c. So it is x square by 2 log x minus 1 by 2 into, again x differentiation is x square by 2 plus c. So it is x, you can write x square by 4 plus c. Okay, like this you have to solve the problems whenever they are given as a two functions. So two function you have to find the integration, means you have to apply the integration by parts method. And like this, if anywhere the given function is that is you are unable to find the integration of that one, then you can interchange this one. Okay, so and integration of, even if e power x is there, sin x is there. So for such of problems also, if you take the g of x value as e power x, why? Because e power x in integration and also in differentiation it will be same. When exponential function is given, you try to take it as g of x. So such type of examples also you have in your textbook, you can see them. Okay, so one problem on integration by partial fraction method. Okay, so this they will ask for the 10 marks question. One problem I will tell on integration by partial fractions. Okay, so whatever the problems just now we have seen, these all are the 5 marks questions. Integration by partial fractions method. Okay, this is the one 10 mark question you will get. And here you know that the partial fraction will be in the form of p of x by q of x. Okay, that is a numerator and denominator. If degree of, you write this one at the side, if degree of p of x is less than degree of q of x, we call it as a proper fraction. Okay, if degree of p of x is greater than degree of q of x, then we call it as an improper fraction. Okay, two different will be there. So and the given function will be in the form of p of x by q of x. Okay, and you see here the degree of that one, numerator and denominator. If it is less than, we call it as a proper fraction. If it is greater than, we call it as a improper fraction. Okay, so now example is one problem we are seeing how to find the integration of such type of fractions. So integration of x plus 3 by x minus 1 x square plus 1 into dx. Okay. So here what we have, p of x, the power is 1, but in the denominator it is 3. X into x square, if you multiply, what you will get 3. So p of x value, here it is less than q of x. So it is a proper fraction. You can identify that one. Just to know that one. Okay. Here you write the integrand is a proper fraction or proper rational function. Why? Because here we are taking it as a function. So it can be expressed into or resolved into, you can write into partial fraction. So it can be expressed into partial fraction, that is like this. Okay, x plus 3 by x minus 1 into x square plus 1. Okay, this how to split the partial, there is a given any proper fraction into the partial fraction. You have the one table is there. At the time of the introduction, I have told that one. So in that table, when the p of x and q of x values are there in three to four different types will be there. So for that one, how to split that one as a partial fractions, it is there in the textbook. You can see that one. Only if in the numerator x plus 3 is there, x minus 1, and here x plus 1 is there, means we can write it as a by x minus 1 plus b by x plus 1. But whenever it is square there in the as a second term, then you have to write it as bx plus c. Okay, you check the table once. It is resolved as partial fraction in like this, a by x minus 3 plus, when it is square is there, you have to write it as bx plus c by x square plus 1. Okay, instead of square, if you have x plus 1 means we'll write b by x plus 1. So this we have split into partial fraction. Now we need to find the a, b, c values. A, B, C means direct integration we can't do for this one. So you are converting it into partial fraction and you are making sure that it will be converted into simple form such that we can do the integration. Okay. So now to find this one, first you cross multiply this. If you cross multiply, what will get? A into x square plus 1 plus bx plus c into by x minus 3 into x square plus 1. Okay, this new both denominator you can cancel. Now numerator, that is x plus 3 is equals to a into x square plus a plus bx square minus 3 bx plus cx minus 3c. Okay, you multiply this both. Now you write the like terms set aside. So x square, if you take it common, a plus b. Next x terms, if you take means x common, you will get c minus 3b. Okay. Next constant term. Constant term is a minus 3c. Okay. So now equating the like terms on both sides of the equating or comparing, you can take. Okay. Equating like terms on both sides. So what is x square is there here? X square is not there. Okay. So a plus b, x square term is not there on the left hand side. So that a plus b value is 0. And next x term, if we compare on both sides, that is c minus 3b equals to 1 here. And constant term is a minus 3c equals to 3. Okay. So a plus b is equals to 0. This is 1. And next one, you will write this as 3b plus c is equals to 1. This is the second one. And third one is a minus 3c is equals to 3. Okay, from 1, what we have, a is equals to minus b. So a equals to minus b means you can substitute in second one. Here bc is there, here ac. Three different equations we have got. Okay. So substitute.
Ma'am, excuse me. After splitting it into partial fractions, the denominator of first one is x minus 1, if I'm not wrong. A by x minus 1.
Okay. That's why we got different values. Here you will get 1. We have x minus 3. Okay. Now this both will get cancelled. It will be a x square plus a plus b x square minus bx plus cx minus c. So if you take out x square common, a plus b, if you take x common, it is take minus b plus c, and it is plus a minus. Okay. Now if you compare this one, a plus b equals to first one, same. Here you write that one, comparing like terms on both sides are equating. Like terms on a plus b equals to 0 implies a equals to minus b. Next one is minus b plus c equals to next one is a minus a equals to AC is, and this is there. You can convert it into AC, no? So here you can put A value as minus B. So you can substitute here in the third equation. Minus B in 1. So what will happen? So minus B plus C equals to 1. Here minus B equals to 3. So if we do plus, here plus, what will happen? Both will get cancelled. C equals to minus 1 we need to do. So plus C and plus C will get it as 2C, and this is minus 1. So we'll get it as minus plus C equals to minus 1. Okay. So you add it this one. So it is plus minus of minus, it will become R is, you can write anyway. If you have any confusion, you do like this, minus B plus C equals to 1, A minus C equals to 3. One more equation you will get. This both will get cancelled. So A minus B equals to 4. Okay, this is the third one. So A minus B equals to 4 means from this equation, that equation A plus B equals to 0 and A minus B equals to 4. So both will get cancelled. 2A equals to 4 implies A is equals to 2. Anywhere you can do, but answer should be same. So A equals to 2 means what is B value? A equals to minus B, no? Therefore, B equals to minus 2. So if we substitute these values in any of this one, substitute B in 1. So what will happen? Minus of minus means 2. 2 plus C equals to 1. C equals to 1 minus 2 equals to minus 2. Okay. Therefore, A is equals to 2. B is equals to minus 2. Don't need to follow this method only. Either by just now substituted now here, instead of A, you can substitute it as B, and then you can cancel and you can do that any procedure, but you need to come the answers as A is equals to 2, B equals to minus 2, and C equals to minus 1. Okay. So now you substitute this A, B, C values in the partial. So what was x plus 3 by x minus 1? What is our A value? A value is 2. 2 by x minus 1 plus dx. No, dx means minus 2 into x plus c plus minus 1. You can write plus 1 square plus. Yes, of the class, mute yourself. So here 2 plus 1 minus it take outside. What will happen? So minus plus 1 by x square plus 1. So in the numerator, we are taking minus common. So it will be converted into 2x plus 1 by x square plus 1. Now you do the integration of this one. Okay. Integration of x plus 3 by x minus 1 x square plus 1 into dx. Integration of 2 by x minus 1 minus 2x plus 1 by x square plus 1. Okay. Now you can separate this one, integration of 2 by x minus 1 into dx minus integration of 2x plus 1 by x square plus 1 into. So here if you take this numerator 2 outside, it will be in the form of 1 minus 1 by x minus 1 dx minus, you can split this one, no? That is 2x x square plus 1, and again one is plus 1 by x square. Add, you will both same. This one you are, the numerator you are splitting it as 2x by x square plus 1 plus 1 by x square plus 1 into that's 2 into 1 minus x minus 1 into x 2x by, just I am writing square minus integration of 1 by 1 plus x square into this. So now in the denominator whole thing as x. Kumari, please mute yourself. Okay, so now it is in the form of 1 by x into dx. So 1 by x into dx integration is log x. So 2 log mod x minus 1. Okay, so now if you see the second one here also dx, it is in the form of f dash of x by f of x. Okay, so f of x means 1 plus x square, its differentiation is 2x. So it is also log of 1 plus x square. Okay, minus, sorry, don't write integration, and integration of 1 by 1 plus x square. If you'll see the formulas, that is integration of 1 by 1 plus x square is tan inverse x. Okay, So it is minus tan inverse x plus c. Okay. So like this, you have to split the given partial fraction and you have to convert it to simple form such that you can do the integration of that one. Okay. So like this only you can keep, or you can write it as log of x minus 1. If you take this to here, it will become power minus, other things are same, 1 plus x square minus tan inverse x plus. Okay. So this type of problems we get for the 10 marks question. Next topic here, the important one is successive reduction. Already time is over. So just I will write the formulas. With the help of that, to try to solve those problems. So if we complete this one, we'll complete the unit 1 method of successive reduction. Okay. Successive reduction, in that we'll have the formulas here. X to the power of n e to the power of ax dx is equals to x to the power of n e to the power of ax by a minus n by a I n minus 1. So for this, I naught is equals to e to the power of ax by a. Okay. This you can do with the example you have in your textbook, that you try this one by substituting in this formula. So the example is x cube into e to the power of x dx. Okay. With the help of this formula, here n value is 3, a value is 1 here. Nothing is there means it is 1. So those two values you substitute in the formula, you get the answer. Okay. Next one, important one is this one, integration of sine to the power of nx dx. Okay, n may be even values or odd values, anything. So the formula is sine to the power of n minus 1 into x cos x by n plus n minus 1 by n I n minus 2. Okay. And even this is same for the cos also. Cos to the power of n dx is also, you'll get the same one. And one case one is, if n is even, we will end up with I naught equals to integration of, that is sin x to the power of 0 into dx. It is equals to x plus c. That is I naught value is x. How you got that? Means sin to the power of 0 is x. Second case is, if n is odd, so we will end up with I1. So I1 is equals to sin x dx. So sin x integration is minus cos x plus c. Okay. These are important for solving the problems. And integration of cos nx dx formula is cos n minus 1 into x sin x by x. Minus will be not there, just why? Because sin x integration means minus cos x will be. But cos x integration is plus, no? Plus n minus 1 by n I n minus 2. So you can, and these two both will be almost same, they will have. So whenever it is even, for this also we will get as x. When it is odd, you will get it as, there is or minus cos x plus c. Okay. So you can, with these formulas, you can do the problems. Integration of sine to the power of 5x dx. Okay, just n value is here 5. You substitute that here. You can see cos to the power of 4x dx also. So try to solve these problems. Okay, this is the reduction formulas we have. So one 10 marks question and one 5 marks question we have covered today. So in the next class, we'll see the second unit. So many example problems are there, inverse trigonometric functions are there, so try to solve them. And even two functions at a time will be also there, that in the reduction formula. In page number 33 is there. This is also important one. Whenever these all, whatever the reduction formulas are there, no, these are useful for even the definite integration. Just they will have the limits here. Formula just will change here. Why? Because we are substituting the limits, no, then it will change. So that is also one of the important concept. Page number 33, third one, reduction formula for integration of sine m to the power of x cos to the power of nx dx. So when n comma n are greater than or equals to 2 and are integers. This is the important formula. On this also you have problems in your textbook and MBQ. So try to solve them. These problems also you will get for the 10 marks question. Okay. In the next class, we'll see the second unit. So second unit, only one problem is there. Third one, areas we'll see, and we'll go to the fourth unit. Okay.